Hello, everyone, and welcome to Managing the API Attack Surface. Today's webinar is sponsored by No Name Security and produced by Actual Tech Media. I am Keith Ward. I'm your moderator for today. I'm with Actual Tech Media, and I cannot wait to get started. This is such a crucial topic and something that is just going to be enlightening, I think, for everyone. Before we get to that, though, there are a few housekeeping items I need to go over with you. First off, we want this to be an informative event for you, so we do encourage any questions in the questions box in your webinar control panel. A bunch of you have already been logging on and telling us where you're coming from today, and it's good to see we've got attendees from Wisconsin and Dallas and New Jersey and North Carolina, San Francisco, Little Rock. You guys are coming from all over, and we are delighted to have you with us. Not only can you ask questions in this box and make comments as you're doing, you can also get help here. That's what I was trying to say. So if you have any issues with your sound or with slides, forwarding or anything like that, any technical issues, first thing you want to do is a browser refresh. That'll fix most of the problems that you may have. If a refresh doesn't fix it, just let us know in that Q&A box, and we will jump on that right away and get you some technical assistance. Okay, up next is the handouts section. Right next to that questions tab, you'll see the handouts tab. And there you will find a number of important resources, including a couple of great no-name security handouts today that I especially wanted to draw your attention to. One of them is an ebook called How to Prevent an API Breach. And another one is an overview of the No-Name API Security Platform. I strongly recommend you download those right now. Great stuff in there. Now in that handout section, you'll also find a link to the Gorilla Guide Book Club, where you can get access to all of our vast library of resources on technology topics. In the handout section, you'll also find a link to the ATM Events Center, which has our calendar of upcoming events, including a number which I think will probably attract your attention. Check out what we've got and sign up. Third, at the end of this webinar, we'll be awarding a $250 Amazon gift card to one registrant. As always, you have to be in attendance during the entire event to be eligible for the prize. So the official terms and conditions of that drawing can also be found in your handouts section. Okay, so we've got all that housekeeping out of the way. Let's get to the main event. I am really happy to introduce to you our presenter today, Philip Verlooy, No Name Security CTO for EMEA. Now, when Philip finishes his presentation, I will be joining him for a Q&A. So let's get to it. Philip, the floor is yours.
Keith, let's dive straight in. So I wanted to talk about managing the API attack surface today, also demonstrate why it's a little bit of an unknown when talking about cybersecurity and attack surfaces in general. So the idea really is, if you look at any organizational environment, you typically start by defining what is your security posture. So a way to get there is to build an inventory. So to get visibility of what are all of the devices, all of the applications, all of the data assets that I own, where are they located, and what security controls have I built around them. Now, once you've established that, you can think about the attack vector. So if you look at the left bottom of the screen there, you see a couple examples, things like weak, leaked, stolen passwords, misconfiguration, especially when it comes to public cloud environments and multiple public cloud environments, maybe outdated or unpatched systems, and so on. So if we then think about the attack surface in general, it's about taking those attack vectors and the vulnerabilities that you know of and potentially don't know of, and that's typically how adversaries will get into your environment. So I'll sort of spend the rest of the webinar here to go into why APIs are sort of a bit of a hidden attack surface and how they fit into this picture. Now, if we step back and think about the assets that we're trying to protect, these have evolved over time as well. So it used to be, let's say, application servers and database servers and storage inside of an on-premises data center that you needed to protect. But more and more, obviously, we've sort of migrated into a completely distributed architecture, usually involving one or many public cloud environments. Now, from a consumer perspective, if we think about how IT evolves, that typically is a sort of replacement movement. We went from, records to tapes to CDs to MP3s to streaming, but in enterprise, that doesn't sort of track the same path. What we typically see there is, let's say we started from mainframes, and then we introduced virtualization, public cloud, multiple public clouds, maybe Kubernetes, and maybe WebAssembly is the next thing. The reality that we have to deal with is it's not a clean migration, rather it's an addition. So what ends up happening is that organizations are typically managing all of these systems together, and from an attack surface perspective now have to think more holistically across these systems. So the way as a defender you have to approach this now is, what is the full extent of the applications and systems that I own, and how can I let's say, correctly wrap that with enough protection so I'm covered from an adversarial perspective. Now, the hidden part here is that we've sort of missed APIs for the most part. It's our thesis that this is a little bit of a hidden attack surface, or a network within the network, if you will. So if you think about how these systems connect together, and especially how they exchange data, that is typically, and more so when we talk about microservices-based architectures, for example, on the basis of APIs. And these APIs tend to be a little bit beneath the surface from a network and security perspective in the way that they operate, communicate, and exchange data across existing networks. But it doesn't mean that adversaries don't understand how these systems work and can try to manipulate access via this sort of network within the network. The reason why we've now come to a situation where this sort of is the case is because we've been focused on the wrong thing when it comes to APIs. Meaning, if you think about traditional web applications, we can protect those with inline systems like a web application firewall. And what we typically do there is we look at a transaction. And if the transaction is malformed or malicious, the web application firewall will block that transaction. So it's very one-off transactional based. An API, however, will pass typically these inline systems because the transaction is actually allowed. It's actually okay, and it looks like a typical HTTP transaction because that is sort of the communication method that is leveraged with APIs. So these types of communications, they typically pass those inline systems because we're not really looking at transactional issues like injection attacks, like SQL injection or cross-site scripting or things like that, but it's more about behavioral patterns. So people trying to misuse the logic of the API on the back end and tricking the system in giving them more data than they were supposed to have access to. The other sort of proof point that I wanted to touch upon is if you look at the amount of traffic that APIs today represents, it's actually the majority of the traffic on the public internet. So these are two figures from two CDN vendors. So on the one hand, we have Akamai, who puts API traffic at 83% of all of the traffic on their content delivery network. Cloudflare puts it a little bit lower at 54%. In any case, it's the majority of the traffic now across these systems is API based, because that's sort of how we build applications today. And that's more and more how we exchange data as well. So we really need to think about APIs as the sort of attack vector. So if we then sort of dial back to the attack surface picture here, we've become very, let's say, good at wrapping security controls around our assets, be it in the public cloud, be it on premises, be it edge, be it mobile, So we've created these new sophisticated security systems, like CWPP systems, CNAP systems, CSPM systems, and so on. But we've sort of forgotten about API access to our assets and communication between the assets on the basis of APIs. And we're surrounded by APIs. So if we think about from a consumer perspective, even, we recently had this announcement at Apple WWDC, where they introduced the new version of iOS 17, which has something called standby mode now. But what happens in standby mode is you get a bunch of information on your display, but that information is pulled together from different backend sources, and it all works on the basis of API. So for example, the 10-day weather forecast is pulled from the IBM Weather Channel. The next hour weather forecast is pulled from the open source weather.gov API. If you want to control your lights, if you want to control things like your garage door, for example, that's all happening on the basis of APIs. So even though we've sort of focused on the software layer, for example, in 2011, you had this sort of seminal piece in the Wall Street Journal by Mark Andreessen saying software is eating the world. What we are seeing now is under the covers, it's actually APIs fueling that software that is eating the world, but we haven't paid enough attention to that. Going sort of from the consumer point of view to the enterprise point of view, APIs are sort of powering the modern world. So if you think about how you control a nuclear reactor or how you transfer money between banks or between consumers and banks, how you exchange personal information in a healthcare setting, all of those systems work on the basis of API integration and API communication. And then the amount of vendors and amount of systems that sit in between those communication chains is massive. So we really have to figure out how can we control all of this communication flow in a secure manner. And it's obvious to us this is sort of a superhuman problem. So we need to employ things like machine learning and AI to make sense of all of that, because you can't really capture good behavior on the basis of APIs in static rules, in static controls, and apply them to inline tools. So APIs today really are everywhere. According to some surveys we did with 451 Research, they're growing more than 200% per year. They're also constantly changing. So typically updated, once a week, once a month, sometimes, multiple times a day, depending on the organization. And because of their external nature, especially from a consumer perspective, they're easily found because that's what they're supposed to do. They're supposed to be external gateways into functionality. But that also means that if there's any misconfiguration on those external entry points, they can easily be manipulated and taken advantage of from a malicious attacker perspective. Part of the reason why we've gotten so confused in the way that we protect APIs is that they look very, very familiar, and they look like HTTP traffic from the past. So if you think about a, let's say, general web page that you're trying to read from a browser, you would do an HTTP request, you would do a GET request to the web server, and the web server would respond with a bunch of data, typically HTML and a bunch of JavaScript, to make up that web page that's then displayed in the browser. Now, from an API perspective, that's also using HTTP as a communication method. So you would also see an HTTP GET request. In this case, it will go to the API endpoint. So an example would be API/v2/user to get some user data back in this case. It won't be responded back as HTML, but in this case, because it's a RESTful API, it will be responded back as a set of JSON data. So from a network and security perspective, if you would look at these transactions, even though, let's say, enterprise web services would be not the same amount of traffic in terms of the amount of calls that you would see flowing, but they would look fairly similar. So that's why historically we've been putting in gateways and firewalls in between these transactions and trying to control them in a similar fashion than traditional web applications. Now, the reason why that doesn't work is if you look at an API, it's actually pulling together an entire IT ecosystem. So it leverages a bunch of backend systems that together have parts of the, let's say, application logic, meaning, let's say I'm an e-commerce site and I have the ability for consumers to order goods from me, and then we'll integrate with a partner to ship those goods out to the consumer. There's maybe also a loyalty rewards card involved from a different third party. There's billing involved from yet another different third party, a payment provider, and so on. So all of these systems, they rely on different backends. But the way it's presented to the front end, to the mobile user in this example, is through a unified sort of API, a set of API endpoints. The way that these inline systems are then validating this transaction is still very, very valid, meaning you still have to do all of these things like check for SQL injections, check for cross-site scripting, provide DDoS protection, provide rate limiting, provide proper authentication and authorization controls, provide traffic controls like routing to the correct endpoints and so on. But they can't really then understand what is the functionality behind that API and what am I allowed to do as an end user. So it's very hard for those inline systems to then validate if whatever you're trying to do from a functional perspective, how am I using this e-commerce site? It's very hard to understand if I'm using it in an expected proper way or that I found some sort of way to manipulate and trick the system into doing what I want it to do. So if you then think about the consumption styles from APIs, these vary as well. So typically we talk about 3 different styles. There's public APIs that are typically consumed by consumers in a B2C sort of scenario. There's also partner APIs, meaning if I'm building a startup today, and let's say I'm going to compete with popular ride-sharing apps, I'm probably not going to build the maps myself. I'm also probably not going to build the billing infrastructure myself. I'm going to partner with existing service providers like Google Maps and Stripe for those particular pieces of functionality. So I need to integrate with those partners from an API perspective today. So that's why these partner APIs come into the picture and why they're sort of important. Then the third one is sort of internal APIs or private APIs. These are typically then used for, either internal functionality, or that's how your developers, integrate with your APIs and build new functionality on top of those systems. So from a security perspective, it's then very, very hard to figure out a couple of straightforward questions that would otherwise be simple to answer, like how many APIs do we have in our environment today? What data are these APIs exchanging? Is any of that data related to regulatory requirements that we have to adhere to? Does it contain PII data and so on? What is the security policy for the connections coming from the consumer side versus connections coming from the partner side? Where do we enforce these policies? So these types of seemingly straightforward questions become really, really difficult to answer because APIs are so distributed and there's so many systems that sort of rely on that API, but also so many systems that pass that API traffic between them. So the thesis again is the API has now become sort of the default attack surface to some extent. If you think about building applications in the past, let's say you're an organization that sort of follows the current best practices or the current state of the art when you're thinking about building new apps and new functionality. So let's say in 2013 you came up with this great new app idea and you looked at AWS as an example as a public cloud provider, and you said, I'm going to run my application logic on an EC2 instance, and I'm going to host my data on an EBS volume that I'm going to attach to my EC2 instance. And that's how I'm going to serve out my application and my data out of my system. At a certain point, a couple of years later, you heard about like the benefits of containers, for example. So you switched or you created a new version or new functionality on the basis of ECS, for example. And then yet a couple of years later, you said, well, serverless really is more appropriate for the types of workloads that we're hosting and the types of exchanges that we're doing. And instead of EBS, we're going to use S3 storage, for example. Now, in the olden days, the way that a malicious user would try to gain access to these systems was through these front-end environments, right? They would breach your perimeter network. Maybe they would have to, deploy some sort of zero-day attack and get access to those environments to then get to the data and so on. In the new model, they don't have to do that anymore because, in essence, there is no front-end logic in between the malicious user and the data anymore. There's simply an API today. And if you look at the API, it sort of provides two big sets of ideas. It gives access to the data, and it gives access to functionality. Now, from an attacker perspective, you're probably interested in manipulating the functionality to get to the data set. So the way that malicious users approach these newer types of environments today is by focusing on that API, because that is the path of least resistance typically. And that's typically what they would go after. So today we are in a situation where you have many, many, many APIs. A couple of reasons why we got there is, first of all, we created hybrid infrastructures, meaning we have different ways of architecting our applications today. This could be, on-premises, hybrid cloud, multi-cloud, multiple different clouds, and so on. The way that we are building applications has changed as well. So today we are looking at distributed environments through microservices. We are looking at continuous development, which also somehow leads to continuous abandonment, especially when we talk about APIs. So think about new versions of the API that you're releasing. Are you still paying enough attention to, let's say, previous versions of the API, and are you still wrapping enough security controls around them going forward? There's also changes in industry standards and guidelines. So think about things like, PST3 was just released, open banking, FHIR APIs in healthcare, and so on. There's M&A activity. The company that you're acquiring probably has a different set of design rules around APIs and a different set of APIs altogether. So you still have to manage both of them. There's continuous changes in API standards as well. So we sort of went from SOAP APIs to REST APIs to GraphQL APIs to gRPC and so on. And then there's also Jeff Bezos who talked about what's now been called the API mandate in 2002, where he stated that inside of Amazon, if you wanted to create new functionality, you had to do that on the basis of standard interfaces, as he called it. He didn't necessarily call out APIs, he called it standard interfaces, and he said, you create something and everybody else in the organization has to be able to interface with your functionality on the basis of those standard interfaces. And he gave a list of reasons why the employees of Amazon should follow his new way of thinking, but he closed off his memo with a final point that said, if you don't follow these rules, if you don't do this, you will be fired. So everybody sort of moved into that direction, and that's sort of why we are now seeing that explosion of API usage. We're also then, of course, seeing that malicious users or people with less good intent have figured it out as well, and we're seeing all of these public breaches appear on a almost weekly, if not daily basis. The Optus breach in Australia is now very famous in the meantime. So this was just an external, unauthenticated API that the company supposedly did not know was externally accessible or did not even know it existed. A hacker could just walk in, query the API for all of the PII information of all of their customers, and walk out with that data. So these types of things keep on happening because it's such an easy part of the attack surface now. As mentioned before, we are going through this evolution of different API architectural styles as well. So from a security perspective, if you want to be serious about approaching this, you have to really understand how these systems communicate, how they exchange data, and what their sort of expected behavioral patterns start to look like before you can sufficiently figure out how to protect them. So what is good versus bad behavior? So that needs to feed into sort of your decision matrix or your ML model, if you will, is really understanding, well, how do those systems operate? One quick example is the Twitter API. So even with one application, you could have multiple different API architectural styles. So for example, if you do a search on Twitter, this is the web client of Twitter, what you'll see is that there's list.json, which is served back on the basis of a GET request to this saved searches API endpoint. So the idea here is that this endpoint is a set of URLs, and they all expose a single piece of functionality, in this case, the saved searches functionality. And then JSON data is served back, and this then represents the searches you did before, which are then displayed in your browser. So this is a simple REST API endpoint call. Now within that same app, if you do a tweet from the same web browser, you're actually calling a piece of functionality called create tweet, which is a post request. So again, it's still using HTTP, but in this case, it's actually leveraging a GraphQL API, which is represented as a single endpoint. So instead of saved query, search, every piece of functionality has a different URL that you can verify. GraphQL exposes itself using a single endpoint. So in this case, you'll always see GraphQL / and then a bunch of gibberish, which is a query. So this could be sort of a named query that has the functionality behind it for create tweet in this case. So again, from a security validation perspective, you really have to start to understand, what does this look like? What am I expecting to come back over the wire? And how can I validate if this is what I'm expecting to happen, yes or no? So again, that's sort of why we are forced in this behavioral approach to really try and get to the bottom of what is happening here. One way of looking at it is existing sort of security tools or solutions are really missing the context when it comes to API security. So this is sort of the fable of the blind man and the elephant. In a sense, you have to step back before you can really understand how do all of these pieces of the puzzle fit together, and together in this example form the elephant, if you will. So we have to look at things like, well, an API is really a combination of a method. What am I doing from a CRUD perspective? Am I doing a create? Am I doing a read? Am I doing an update? Am I doing a delete? What am I talking to? I'm talking to twitter.com. And what is the path that I'm talking to? This already gives you some context about what is the attempt that is made by the end user. So a get, so a read to twitter.com/v2/users all is a very, very different context than a delete to that same endpoint. So the rules in both of those calls should be completely different, but your system should really understand that in the context of the user that is trying to perform this operation. Another example would be a post to UAT, so user acceptance testing.twitter.com, is very, very different than a post to twitter.com, right? So again, you really have to understand what is the logic of my application and how is it supposed to behave before you can confidently state this is traffic that I'm expecting, or this is traffic that should be blocked, or a user that should be blocked. Talking about blocking, if you think about this from a WAF perspective, so in this example, let's say you have the Coinbase app on your mobile phone, and you're doing a post to this specific API to create an order. Now, what the web application firewall will do is it will say, oh, this is HTTP traffic. So it will look in its signature rule set and say, what rules am I supposed to apply to this HTTP traffic? And of course, a post to this endpoint is supposed to be allowed, because otherwise that functionality would not be available. It would look at a transaction, and this single transaction will probably be allowed because from a transactional perspective, a call to this endpoint is allowed. So you have to look at it in a broader context to say, well, looking at all of the historical transactions coming from this particular user and the path that this person followed from an endpoint perspective, should I allow this, yes or no? So you really have to, from a relational perspective, try to understand how do those things fit together before you can confidently, allow or deny from a traditional firewall perspective, let's say. Now, of course, I work for an API security vendor, so of course I'm going to tell you that APIs are sort of a very, very important attack factor. And I'm not in the business of selling web application firewalls, so of course I'm going to say that these web application firewalls aren't sufficient. So what I've done here is I saw this recent presentation of Microsoft where they came to the same conclusion. So Microsoft in Azure, in this case, they have these services already, right? So they have network firewalling services on the perimeter. They have API application gateways. They have web application firewall services. And even they are stated that they're seeing that APIs are sort of the predominant consumption method going forward for mobile, web, and IoT systems. These inline tools, although very, very important, aren't sufficient, right? They're important for controlling the web traffic. They're important for things like DDoS protection, rule-based checks, injection checks, and so on. But when it comes to things like business logic abuse, how is the application support supposed to work? Broken authentication and authorization attacks. What am I allowed to do from a very, very granular access to data, access to object perspective? And how am I supposed to validate that inline? And excessive data exposure risks, these cannot be caught using those inline tools. So that's why you need this layer on top that sort of understands what is going on from a behavioral perspective and then feeds into those existing systems, gateways, firewalls, and so on, to then leverage those for blocking operations and blocking purposes. So this sort of table gives you an overview based on the OWASP API top 10. So what are the top 10 categories that the OWASP has defined as the most important sort of API security issues, and where do these tools sort of fit in? And what you can see here is that, depending if it's a code level issue or it's an inline WAF validation or gateway issue, there's more or less, let's say, applicability for those tools, but they miss most of these categories of API-specific attacks. Again, they were never focused on this, so they were really, really focused on traditional web applications. I'll pull out one quick example. So this is from the new OWASP Top 10, which was just updated for 2023. And a new category that they added is called BOPLA, or Broken Object Property Level Authorization. And this is based on an example from Shopify, a Canadian e-commerce platform that people can use to build e-commerce websites. So, for example, what could happen there is that you have a malicious user, in this case, a fake partner to your e-commerce site. So let's say I'm building an e-commerce site and I have a partner that is like a wholesale reseller to me. Now, let's say this fake partner wants to associate him or herself with your website for malicious intent. So in this case, what happened was, the WAF and the gateway would allow this traffic to go through because it looks perfectly fine. But from a, let's say, malicious activity perspective, the first issue is the broken function level authorization issue. So what was possible is you could do a post to this endpoint and accept yourself as a partner on behalf of that e-commerce provider. So as a fake partner, I could associate myself with this e-commerce seller. Once I've associated myself with this e-commerce seller, I could associate multiple different fake partners as well. So also from an object level authorization perspective view, I could say I'm going to accept not only myself, but also a bunch of different partners. And then even more granular, what could happen from a BOPLA perspective, which is the new attack that we're talking about today, is to change the inventory count using that fake 666 ID here from that fake partner, whereas in reality, only the e-commerce owner from an authorization perspective should be able to do that. So what could happen, for example, is I'm a fake partner. There's a big sale happening on a new type of Nike shoe that I know that you're also selling. I'm going to associate myself with your e-commerce site. I'm going to put your inventory count of that Nike shoe to 0. So you're not part of selling that Nike shoe. So everybody will come to my website to buy that new shoe, for example. So these types of sophisticated attacks sort of leave you open to a lot of misuse. Now, because it's such a new field, there's a lot of activity happening, and there's also a lot of people in the research community, let's say, providing guidance and tools and knowledge around API security, API attacks, API, validation, testing, and so on. So, for example, this is a screenshot that I took from a webinar from Insider PhD, where she said, like, you want to test for these business logic errors in applications by walking through the features using, for example, a sort of proxy system, like Burp Suite or Zap Proxy, whatever tooling you want to use there, and then try to figure out if you can skip certain steps and still have the backend respond to you. So what happens if I'm on an e-commerce site and I skip the payment step from an API perspective? Can I still go to the shipping step, for example? So can I trick the system into giving it what I want? One quick example here is Coinbase. So Coinbase had this actual business logic issue. The security research that found this went through disclosure, so this wasn't misused in production. But what happened here is that the security researcher created 2 different accounts in Coinbase, was able to switch mid-transaction to another account and sort of trick Coinbase into accepting a trade with crypto coins that he or she did not own. So he or she was able to trick the system into selling expensive Bitcoins for the price of cheap Shiba Inu coins, just by switching mid-transaction using a proxy-based sort of attack, just because that logic validation step wasn't in the API and in the application backend. So wrapping up here, so these are sort of the let's say critical capabilities that analysts are talking about when it comes to sufficiently protecting an API environment. So things like discovery, things like posture management, testing, runtime protection, and access control are considered to be critical capabilities when it comes to sufficiently protecting your environment. So what do we mean by each of those domains? So discovery is, how many APIs do I have? Where are my APIs? Who has access to those APIs? And then posture management is about de-risking them. So do I have any misconfigurations in my APIs? Do I have routing misconfigurations in my environment that bypass my gateways? Am I using outdated ciphers to encrypt my data? Things like that. Testing is obvious. So testing is more a pre-production type function where you validate if you have security issues during development of your APIs. And runtime is really the big crucial topic here, where we leverage things like behavior analysis on the basis of machine learning to really understand expected good behavior, so we can then validate malicious attempts and stop those hackers essentially during that hack attempt. And then access control is a sort of baseline functionality that we all expect. So implementing proper authentication and authorization controls to make sure that only authenticated users are allowed to communicate with your systems. This maps very, very cleanly to the capabilities of the no-name security platform that we've created. So we've put in those critical capabilities as part of our 4 pillars of our platform. So we do have the discovery module, the posture module, runtime and testing modules. And then for access control, we would then rely on those critical inline systems that all our customers already have. But we would then also be able to validate those access control capabilities to make sure that if things are missed on that end, we could still implement blocking and monitoring and remediation to make sure that that doesn't lead to successful data extraction, for example. So what I'll do now is I'll just take a few minutes to show you our platform. Super high level, very, very quick demo. But I just wanted to show you what the no-name platform looks like by touching really quickly on those 4 different pillars of discovery, posture, runtime, and testing. So our system, the way it operates is it's super easy to integrate into an existing environment. We call that a traffic source. So the idea is we integrate into those gateways, into those firewalls, into those load balancers, into those service meshes, into any public cloud environment, get a copy of the API traffic, and that's the only thing we need to start validating if traffic is valid, yes or no, if behavior is good it's good intent or it's bad intent, and so on. So once you've given us some traffic sources, we'll immediately start building a full inventory for you. So this is the discovery, including what is the type of data I'm exchanging across those systems. Does that data relate to any data regulations that I need to adhere to? Maybe things like PCI DSS and so on. What are the types of APIs that I'm using? And how should I approach this from a security perspective? So what should I focus on first? So we'll do this classification extended as well. So you can easily jump in and start figuring out, well, what are the most pressing issues? Besides this super high level inventory, we have a per endpoint inventory as well. So we'll show you in excruciating detail for every API endpoint what that looks like, and also how it relates to the rest of the environment. So for example, we can show you the network graph. So how are people consuming your API externally versus internally? What are all of the systems that are involved with powering that API? Are there any vulnerabilities in any of these points? Is there traffic passing, for example, these load balancers and hitting the backend API directly? So this can be easily identified as well, including how many people are talking to my API. Does my API documentation match the reality of what we're seeing on the network, or are there some undocumented fields, etc.? So that's all part of the inventory as well. From a posture management perspective, so that's the second pillar, it's more about can I spot some misconfigurations? So for example, here there's an Azure app service which is directly accessible from the internet. So that means there's probably some sort of routing misconfiguration you made in your public cloud. And this is then a remediation or a guidance to remediate that particular problem. From a runtime security, so this is leveraging that machine learning. So this is really getting into the behavior of those APIs. Let's say one quick example would be Ebola type of attack. So what we're pointing out here is on the basis of our machine learning, we have determined that usually a user only accesses one of these objects, meaning account/GUID. And we have seen this particular user access 21 of those GUIDs. So according to our ML model, this means it's malicious. We have the full evidence chain of that as well. So we can show you all of those transactions. So you can follow along and see exactly who is logged in, how is this person authenticated, what data is he or she serving back, and does that match my expectations, yes or no? And then, of course, you can block this attacker by leveraging those inline tools that you already have in your environment. In this example, it would be the AWS Web Application Firewall service. So that's the runtime piece. The final piece is the testing one. So we call it active testing. So what we can do here is we can associate an API under development with our platform. We will then go out, scan this API under development, and then point out all of the issues that you still have in that environment. So for example, here we've run our tests and we have 167 of them today. You can create your own as well. We'll run our tests against that system, and then we'll point out exactly on a per API endpoint basis where these issues still reside and how you should go about remediating them. And then, of course, because this is more focused on the development side, this neatly integrates into CI/CD pipelining tools. So it becomes an automated part of that API development and API deployment. So you don't really have to do any manual steps to validate any of that. So that was my super high level whistle stop tour of the demo environment. Of course, always happy to do a deeper dive demo as well. But with that, I think, Keith, I saw a bunch of interesting questions come in. So maybe it's time to use these last few minutes for Q&A.
Yeah, absolutely. Thanks so much for that presentation, Philip. Great stuff. Love the demo and alerting us, or I guess creating a new awareness of how serious this API issue is. Before we get to audience questions, I had one that I thought of while you were talking and wanted to ask you about this. One of the first rules of IT security is you can't protect what you don't know you have. So is it no name's experience that the typical IT organization has a lot more APIs than they're even aware of?
Yeah, absolutely. So that's a very good point. So even talking to analysts, and they get a bunch of inbound calls from their customer base as well. So this seems to be the one big thing that everybody is struggling with, is trying to understand how many APIs do I even have. And to your point, we typically find between 30 to 40% more APIs than that they thought they had. Especially when you also take into account things like internal APIs versus partner APIs versus maybe third-party APIs, will quickly run into the hundreds, if not the thousands. So yeah, absolutely, it's always the case that we find a bunch more than the customer expected to find.
That's scary. That is scary. So first question from the attendees. How would we get started with implementing API security? And related, as you're looking at implementing this security, how do you prioritize? So how do you know, what do you start with first?
Yeah, that's a good point. So this is a fairly broad topic, right? So even analysts like Gartner sort of talk about these critical capabilities, but in reality, it's almost like a set of point solutions that you would need to implement to really get started with this. So the way that we approach it is leverage what you already have and extend the context of those systems by integrating with those platforms. So step one for us is always the visibility step. So perform the discovery operation before you even think about, how secure are certain APIs, how should I go about implementing, validation or protection steps. Back to your, original question, it's like you cannot protect what you cannot see. So step one should always be get that full inventory. And once you have the inventory, we can look at security misconfigurations, we can look at our ML models and so on. But step one should always be inventory and discovery.
Absolutely. Okay, next question. Who would be responsible in an organization to manage and oversee an API security program? Every organization is different, no matter the size, different titles, different departments, different levels of granularity. So who typically would run something like this?
Yeah, that's a very good question. So we also see that APIs have a lot of stakeholders, right? So especially if you think about monetizing APIs. So if I'm an organization that wants to put functionality out there and have people pay for my functionality on the basis of my API integrations, you have API designers, you have developers, you have people who have to run these APIs on infrastructures, you have the mobile teams, the cloud teams. So there's many people with many different tools that are sort of touching APIs at a certain point. What we see from a security and API programs perspective is that it typically falls under the purview of the CISO organization and the application security team. That is typically where this fits. Reason being is there's a bunch of tools that you already have that you can extend this context into, right? So if you think about leveraging API gateways, web application firewalls, and so on, with this added intelligence of an API security platform, that sort of dictates or guides a little bit where this sort of falls in the organization. So I would say application security for the production side, and then probably developers and DevOps and DevSecOps personnel when it comes to the pre-production testing side of the equation.
Right, that makes sense. Okay, next excellent question here. Since you're dealing with sensitive data, how do you know you're not becoming just another part of the attack surface yourself?
Yeah, that's a valid point. So there's, of course, an ever evolving attack surface, and APIs is sort of definitely part of that. The way that we've approached this is because we work with a lot of customers in sensitive environments, not only financial institutions, but also governmental institutions and defense institutions. We've chosen to build a model where the data remains in the customer's environment. And that customer environment could be on premises, it could be in the public cloud, but in the customer's own cloud account. So the idea is we do not want to externalize sensitive traffic or PII data and mix it with or mix it between different customers. So everything is customer centric when it comes to handling that data. And then the other thing that we employ is we have the capability to perform data obfuscation. So if you don't want sensitive data to be part of the evidence capture, so typically what we do is we will validate your API purely in memory. There's nothing written to disk, so there's no sensitive data written to disk. Once we do a detection, however, we want to give you that evidence. So we do write that evidence to disk. But even then, you can opt to say, well, if it's sensitive information like a credit card number or a social security number, I do not want you to write it in clear text to disk. I want you to obfuscate that data. So there's many levers that we can pull to safeguard your data.
Right. Okay, thanks. Organizations these days have lots of security tools out there. And so there's a legitimate question and that was asked, do we really need another dedicated security solution? How much can and this is obviously something directly for No Name. This seems like more stuff on the network, more things, monitoring and all of that. So what about that issue of tool sprawl and too many solutions?
Yeah, that's definitely a great point, and I'm also of the belief that we, as an industry in security, we are sort of guilty of pushing out a bunch of point solutions for each new specific sort of attack factor that gets figured out or gets leveraged. So the idea is, how can we get these tools to work together and be a sort of quote unquote positive member of the security ecosystem? That's sort of how I look at it. So the idea is we integrate with the tools that you already have, be it public cloud services, be it existing on-premises security tools like application firewalls and gateways and load balancers. And essentially, by giving them that additional API security context, not only extend their usefulness, but probably also extend, like, your existing investment becomes optimized, becomes more valuable by connecting our solution into this. And then the way that you operationalize this, I'm not necessarily saying, even though we have a really nice user interface, that's the way you should operationalize it from a day-to-day perspective. What we see most of our customers doing is integrating it into existing workflow tools that they already have. So let's say you already have a SIEM tool or a SOAR tool or a ticketing solution or an ITSM solution. So these could be things like IBM Q Radar or Palo Alto XOR or ServiceNow. Leverage those tools. So we will integrate in that existing process flow, in that existing workflow solution, and then you can pick it up using the processes that you've already built out. So I think that's a more realistic way from a customer implementation perspective to approach this. Not so much as a additional point solution, but how do I use this to pull together the environment that I already have and to leverage the processes that I've already created in my organization.
Great, thanks. Okay, that's all the questions from the attendees we have time for, but I did want to ask you one last thing. You presented a lot of really great information today, and you've really highlighted the importance of API security. So for those who want to learn more about No Name, who want to take that next step, what should they do, Philip?
Yeah, so we obviously have our nonamesecurity.com website, which is a good starting point. But I do want to give a quick shout out to a concept that we are doing called the API Security Workshop. So if you go to nonamesecurity.com/workshop, you will find 3 to 4 hour online workshops that we run, which are free of charge, where we'll show people how to manage, but also how to manipulate an API-based application. What are sort of the attacks that are possible? What are sort of the vulnerabilities in those systems? And how you can leverage API security to sort of protect yourself. Again, it's open for everybody. It's completely free of charge, and it really gives you a lot of insight into this new and burgeoning field of API security in a really, let's say, low effort way.
And free is always good,
Always good.
in these situations. All right. Well, Philip, it's really been a pleasure to have you on today and to learn much more about API security than I knew before, and to realize how pervasive these APIs are and the crucial need now to lock these down in a way that probably most environments haven't done to this point. So thank you again for your time and information and for sharing with us today.
My pleasure, Keith. Thanks for having us.
But that was a great Q&A, a great presentation. And I had a lot of fun with Philip going over those things. Lots of really timely stuff there. API security is something that we all need to be concerned about these days. And so it was just great to have Philip on. So before we wrap up, for the day, we do have one more piece of business for you, and that is the Amazon gift card prize drawing. And the winner of today's $250 Amazon gift card is Subash D'Souza from California. Congratulations, Subash. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank No Name Security for making this event possible. I want to thank all of you, the attendees, for spending some time with us and for your great questions. Just so much interest in this, so many great responses from you. So it's just nice to see that you're really into this particular topic. And we look forward to seeing you on the next event. So that concludes today's presentation. I hope you have a great rest of your day.